Hello everyone, welcome back to the today's LeetCode problem. It's a problem about 2D array, that is transpose matrix. Given a 2D integer array matrix, return the transpose of matrix. So what is the transpose of a matrix? It is flipped over its main diagonal. When the matrix is flipped over its main diagonal, that is known as the transpose. So it means switching the matrix row and column indices. So the row of this matrix will become the column of its transpose. That is what we are understanding about the transpose. Let us see one more clear understanding of the transpose. Let me show you one thing. Yeah, of this. Yes, this. So you can see the column of the given matrix is becoming the row of its transpose, row of the answer matrix. Okay. Now let's go move towards the solution. So for that, let me change the image. Okay. Now this is going to be interesting. So in the answer, we have to return a new matrix. That is for sure, because we don't know, because we can see here, as we will convert this matrix into its transpose, the number of columns and rows gonna change when the matrix is not a square matrix, right? So here, the number of rows of the given matrix will become the number of columns of the answer matrix, that is transpose. Okay, so transpose of this given matrix, I will say it as answer matrix for the sake of simplicity. And the number of columns of the given matrix will become the number of rows of the answer matrix. So the three columns will become the three rows, and the two rows will become the two columns. Now we will see how this answer matrix will be populated by the index of the given matrix. Okay, so the uh, 0 0 index of this will be 1, and it will, when we will flip it, so 0 comma 0 will remain 0 comma 0, and at this position I am keep on writing here also. So I'll take a pen. Fine. Okay, so this 0 comma 0 is 1, is it's 1. So in the answer matrix it will become 1 when we will flip 0 comma 0, and 0 comma 1 is 2 in the given matrix. In the answer matrix it will become 1 comma 0. So 2 will reach at 1 comma 0. So where is 1 comma 0? This is 1 and this is 0, 1 comma 0. So 2 will reach here. Okay, and this 3 that is currently at 0 comma 2, it will reach at 2 comma 0. So 2 comma 0 is here, 2, and this is 0. So this 3 will reach here, right? We are flipping 0 comma 2, we have flipped it, 2 will reach here, 0 will reach here, so it will become 2 comma 0. That's what I meant when I'm saying flipping. So for the next row, 1 comma 0, when it is flipped, 1 comma 0 will be flipped and it will become 0 comma 1. So this 4 will reach at the 0 comma 1 index of its transpose, that is answer matrix. So 4 will reach here at this position. And this 5, which is currently at 1 comma 1, so we will flip 1 comma 1, it will remain 1 comma 1. So 1 comma 1 and 5 will come here. So we can observe that the elements which are at diagonal currently, where the value of I and j, that is value of row and column, is same, the it will be in a square matrix. If we'll see the example of square matrix, the diagonal elements will remain at the same place. So this 6, which is currently at 1 comma 2, will reach at 2 comma 1, that is 2 and 1, and 6 will come here. And this is the transpose of this given matrix. It's this simple. Okay. So to code this problem, understand that we need to create a new matrix for sure. So in the solution also, I'm going to create a new matrix, and the number of rows will be the number of columns of the given matrix, and the number of columns will be the number of rows of the given matrix. And then I will iterate over the given matrix, and at the current index, I will set the corresponding flipped. I will flip it and I will change the index of our answer matrix. That is how we are going to achieve our transpose, right? So let's directly dive into the code without wasting any single second, because that's not a good thing. Fine. So first I will uh, define number of rows. Number of rows for the given matrix will be matrix dot length, right? And what will be the number of columns? So number of columns, I'll call it calls, will be the elements in the first row. So first row or any row, you can take any row, but it is always good to take the 0th row, because we don't know how many rows there will be in any given test case, because uh, at least we have this idea that that will be more than one. There will be more than one row, right? More than one row or equal to one row. So at least we will have one row, and we will not get that scary exception of array index out of bound. Okay, fine. That's why I'm taking it matrix of 0.length. Fine. So these are the number of rows of the given matrix, and these are the number of columns of the given matrix. Now I am going to define a new matrix, that is the that will become the transpose. So I will name it as uh, transpose. Transpose. Fine. Okay. So it will be a new array, and it will have number of rows. How many number of rows? The number of columns of the given matrix. So I will write columns here, and it will have number of columns equal to the number of rows of the given matrix. So I will write rows here. Fine. So the definition is clear. Now we have to populate this transpose. Currently, I have just blocked the memory for this transpose. Fine. Now I'm going to populate this array by iterating over the given matrix. Okay, I will iterate over it, and I will keep on setting the elements, the indices of this transpose by flipping the current index of the given matrix. So let's see. For that, we have to run a nested for loop. So let's take this as R, and from 0th row to row less than rows. Fine. And R plus plus. This is our one loop. Now we need one more loop to iterate inside. Int column equals 0 to column less than calls, and C plus plus. Oh, Java got scared. No, Java is not scared of anything. Fine. So now I will take the current element. So current element, let's say int le. So the current element will be matrix, matrix current element, matrix of R, comma C. So this will be the current index. Fine. Now we have to set this element into the corresponding position of our transpose. So the corresponding position in transpose will be, what will be the corresponding position? we have to flip the index. If we flip these indexes R and C, we will get the corresponding position in the transpose. Fine. Very simple. Okay. Transpose and square bracket. Here C will come and here R will come. And we will set element to it. That's it. This is the total code. Okay. And finally, we have to return our answer. What is the answer? Answer is the transpose because we have populated it. Done and dusted. Now let's run this. And it's taking a little bit time. Got accepted because I've already tested it. And let's submit for the entire test cases. And it will get accepted. And it is quite fast. And it's good. I hope you guys have understood the explanation. I've tried to make each and everything clear. So if you like this video, then share to your friends and keep solving more and more problems, improve, get get improved and get hired and get successful. So this is it for this video. I'll see you in the next one. Till then, just keep enjoying, keep chilling. Thank you and bye bye.